The next thing that we're going to do in Chapter 1 is to look at doing simple conversions. Now, many of you know how to do simple conversions with, let's say, foot and inches, but the metric system is what we're going to focus on in doing simple conversions. So the first step in doing these conversions is to learn the metric system and see how it's arranged so it's easy to use. Doing unit conversions is probably the most important thing that you're going to learn in this course, especially for those of you who are going on into nursing. So the first thing that you need to realize about doing math in chemistry or doing any kind of unit conversion is that when you write a number, you must follow it with a unit or it's meaningless. If we were to say that a child weighed 10, you really don't know whether I'm talking about 10 pounds or 10 ounces or 10 kilograms. You have to have a unit with the number or it is meaningless. And you will find that if you focus on units in doing chemistry problems, it all comes a lot easier. So the first thing I want you to do is take a mindset and say, I'm going to focus on these units, and you're going to see that this will become a lot easier to understand. These are the units that we're going to be using in the course. They're both English and metric units here. We will most likely only be using metric units. Now there will be some English units in some of the problems to do, and you will have to know some English unit conversions, but for the most part we're going to be focusing on metric units. The metric units are grams or a prefix with gram, meter or a prefix with meter, liter or a prefix with liter. Grams is mass, meters is length, and liters is volume. There is another way of us expressing volume, and that is by cubing a length. So centimeter cubed is a volume. In the medical area, they often will call it a cc for cubic centimeter. We do not use that unit either in the medical area. They've gone away from using it, and they are now using milliliter. But we do not use cc because you cannot do math on cc. You use centimeter cubed as is written here, like this, centimeter cubed. Area is a square length. You are going to be doing word problems, and many people are afraid of word problems and think they're very hard, but you're going to find that word problems are not that difficult. I'm going to work through how to approach word problems so as to make them easier. The first thing that you need to learn is that the word per means divided by. Anytime you have a unit after this word, per, then that unit belongs in the denominator of a fraction. So, for example, we have here 2.21 pounds per kilogram. Because kilogram comes after the per, it goes in the denominator. And if it says, if there's two pers after a unit, for instance, if it says 150 milligrams per kilogram per hour, everything after that first per goes in the denominator. We'll see that later when we're doing drug conversion problems. Per even means divided by in percent. Per cent means per 100, and you can see right over here, this is one way of changing 1.14% to a fraction, is to just say it's divided by 100. It makes a lot of sense. Here is a dosage, 125 milligrams per kilogram. The kilogram, because it's after the per, goes in the denominator. That kilogram is a mass of the person, and this milligram is a mass of medicine. Here's another one. This is a velocity, 200 milliliters per hour Because hour is after per, it goes in the denominator. You're going to see that we're doing a lot of fractions, so learning that per means put it in the bottom of a fraction, in the denominator of a fraction, makes it a little bit easier to do your work. The metric system is based on powers of 10 and the base units. I've already given the base units to you, gram, meter, and liter. And we have some prefixes that we use with that. For instance, kilo, deci, centi, milli, and micro. There are a lot more prefixes than these. I'm just giving you the ones that we're going to commonly use and are commonly used in the medical area. Kilo means 1,000 or 10 to the positive 3. Deci means 1/10. Centi means 100ths, 100th. You can see I'm giving it to you in powers of 10, and I will use them sometimes. It doesn't matter if you use a decimal number or if you use a power of 10 number. Use what you feel comfortable with. They mean exactly the same thing. Milli means 1,000th or 10 to the minus 3, and micro means 1/1,000,000th or 10 to the minus 6. The symbol for micro in science is this Greek letter mu. However, in the medical area, they do not use a mu because it is mistaken with sloppy handwriting as a capital M, which means mega, or as a little m, which means milli. So what they use in the medical area for micro is MC, and you are welcome to use that if you would like.
In order to derive a relationship between a prefix with a unit and the base unit, all we have to do is rely on the meaning of the prefix. So to get the relationship between kilometers and meters, the first thing I do is I write down what is the meaning of kilo. So I write kilo equals 1,000. Now what I do is I multiply both the prefix and its meaning by meter. Or you can say you just write meter after after both the prefix and its meaning. This gives you a relationship between kilometers and meters. You can use this same technique for any two units in the metric system as long as one has a prefix and the other one does not. I'll show you how to go from let's say from millimeter to micrometer or something like that later. We have to go through the base unit, but right now I just want you to get how do you obtain the relationship between a prefix and the base unit and its base unit.
So using that method that I just gave you, I would like you to take meter and decimeter, liter and microliter, and gram and milligram, and write correct relationships by first writing down what deci means by writing deci equals and then write what it's equal to, and then following both sides of the equation with meter. Go ahead and pause the lecture and do these two problems and then press resume.
To do this problem, the first thing that we do is we write down the meaning of deci. Deci equals 0.1. Now you could have written deci equals 10 to the minus 1. That's fine too. The next thing we do is we write meter after both the prefix and its meaning. And voila, you have the relationship between decimeter and meter. To go from microliter to liter, the first thing I do is I write down what micro means. Now, you can use the symbol mu and the meaning 0.000001. I find that rather laborious to write all those zeros, so I just use mu equals 10 to the minus 6. You can also use MC as your prefix instead of mu, because in the medical area they do use that. They avoid writing the Greek letter mu because it is mistaken for a capital letter M or a small letter m oftentimes. Once we have our prefix equal to a particular meaning, we just follow the prefix and its meaning with the base unit. And so now all of these relationships are exactly the same, they're just written differently. And you could use any one of these. To go from milligram to gram, I first write what milli means. And here I've written that milli is equal to 0.001, or I can write milli is equal to 10 to the minus 3. I then follow both the prefix and its meaning with gram, and I have the relationship.
Well, now the book and some of the problems that we do are going to be requiring being able to go from the English system to the metric system. These relationships are ones that you should know. An inch is 2.54 centimeters. A quart is 946 milliliters. And a pound is 454 grams. Or you can say a kilogram is 2.21 pounds. I will be using the relationship between pounds and grams or pounds and kilograms in an exam. I probably will not emphasize the use of inches and centimeters and quarts and milliliters. Since the majority of people in here are going to be going into nursing, I'm going to emphasize a relationship that you must know in nursing, which is the relationship between pounds and grams. You can look up any kind of relationships in the textbook or in your dictionary in the future. However, in order to do problems that are in the book, I would not look up a relationship for every single conversion that you do. You need to learn how to do what are called multi-step conversions, where you go from one unit to another. There are problems on how to do this in the worksheet, and the book does problems that are multi-step also. They go through how to do that in the textbook. You do need to know that a centimeter cubed and a milliliter are identical. So realize 1 centimeter cubed is equal to 1 milliliter. Anytime you have a centimeter cubed, you can cross that out and write milliliter. Anytime you have a milliliter, you can cross that out and write centimeter cubed. They're identical. They're defined to be exactly the same. This is the relationship between the Kelvin, Celsius, and the Fahrenheit scale. You're really familiar with the Fahrenheit scale. You know body temperature, room temperature, and boiling point of water in the Fahrenheit scale, but we will not be using the Fahrenheit scale. In science, we use Celsius and Kelvin. Celsius and Kelvin are very closely related in that the size of their degrees are identical. The difference is the point of 0. In Kelvin, you have no negative numbers, so the lowest possible temperature that is ever achievable is 0 Kelvin. It's never been reached. It's a theoretical temperature. Celsius has the exact same size of degree, but its 0 is at the melting point of water. This means there are negative values in Celsius. To go from Celsius to Kelvin or Kelvin to Celsius is just a matter of adding 273.15 to your Celsius temperature or subtracting 273.15 from your Kelvin temperature. There is a formula for going from Celsius to Fahrenheit and Fahrenheit to Celsius. It's in your book. I'm more interested in, rather than doing conversions, is being very, very comfortable with the Celsius as if you lived in it all the time. For instance, if I were to ask you what do you think would be a good temperature for a hot cup of coffee, you might say something like 85 degrees Celsius, very close to boiling, right? Or I might ask you what would be a reasonable temperature for a day in July, and you might pick 38 degrees Celsius. what would be a temperature that you might experience in your deep freezer. Minus 10 degrees Celsius would be a good answer. You see, I'm going to expect that you'll understand the Celsius scale, not that you can convert from Fahrenheit to Celsius or Celsius to Fahrenheit. That's not as important to me as that you understand what these temperatures mean. So know these temperatures: boiling point, body temperature, room temperature, and melting point of water in the Celsius scale. When we get to the gases, we will be using Kelvin regularly. For now, we're going to be sticking primarily with Celsius.